Hi, everybody. Today is part two of Module 2 videos. This is again from the document that I sent out earlier this week. This deals with the introduction of functions. So let's get going. So this is a continuation. This is underneath the quadratic equations that we saw last time. And this is an intro to functions. Okay, the idea of a function is a really important idea. Okay, I suggest you start out with this link. Click this link, watch the video for that. That's an Alta Newton video. It might help you out. So basically we have a relation. A relation is just a pairing from one set to the other set. The first set is called the domain. The second set is called a range. Okay? Any type of pairing that we can think of that sends something from this first set, the domain, to something to the second set. In this case, it's names and phone numbers. First set, the domain is names. The second set is phone numbers. And Linda gets attached or paired up with this phone number for her home number and this one for her cell number. Eugene only has that number, cell number. Janet has the same number. Rick only has that number, and Marty here has two numbers. He has a home and a cell phone number. Now that's a function. Or I'm sorry, that's a relation. A function is a relation that takes each value. Now here's the difference. Each value from the domain and pairs it with a single value in the range. So above here, when we saw Marty, see how Marty's attached with two different phone numbers? That can't happen when you have a function. Marty can only have one phone number. So for example, in this case, okay, we have names and birthdays. Okay, everybody only has a single birthday. Okay, so Maria's birthday is November 6th. Can't have another birthday. Armando is January 18th. Can't have another birthday. Cynthia, December 8th. Can't have another birthday. Kelly, March 15th. Can't have another birthday. Rachel, November 6th. Can't have another birthday. Suppose we had Sam in here, and suppose Sam's birthday was November 6th as well. Is that okay? The answer is yeah, just like here with Rachel and Maria. One thing can be paired off with one thing here. Over here in the domain, something else can be paired with the same thing that was paired off with something else over here, as long as this only has one pairing from here to here. That's all that matters. Okay. So functions can be looked at as an arrow diagram like that. They can also be looked at as a set of ordered pairs. And relations can as well. So let's take a look at this one. So keep in mind that when we look at ordered pairs, the x values are the domain values and the y values are always the range values. So in this case, 1 gets paired off with 2. If 1 got paired off with something other than 2 in the other ordered pairs, then it cannot be a function. It'd be a relation, but not a function. But that's not the case. 3, the x value of 3, only gets paired off with 5. If the x value of 3 was paired off with anything else, any other y value here, it could not be a function, but it's not. The same thing is true with minus 3. Minus 3 is only paired off with 4. And again, I'm looking at what the x values are paired off with. Okay? There's only one pairing of an x value of minus 3, and that's with 4. Here we have 4, 3. The x value is 4. There's no other x value of 4 paired off with anything else. And the same thing with minus 5. So it's a function. Let's look at b. So we have 2 paired off with 3. 3 paired off with 3. It's okay, 2 and 3 here. The x values of 2 and the x value of 3 has the same y value. That's okay. Same thing with the 5. It's okay. And the same thing with minus 7. The key is 5 only gets paired off with 3. If there was another ordered pair that said, say, 5 got paired off with 4, then it would be a relation, but not a function. Let's take a look at this one. 2 gets paired off with 3. Minus 3 gets paired off with 4. But minus 3 also gets paired off with 5. Since minus 3, the x value of minus 3, has a pairing of 4 and a pairing of 5, it cannot be a function. A function can also be represented as a graph. It has to pass a vertical line test. I draw a vertical line through the function. If it passes the graph only once, if that vertical line crosses the graph only once, it's a function. If it crosses more than once, it is not a function. You're probably pretty familiar with that. Let's look at functional notation. Functional notation, we have this f with x in parentheses equals some kind of algebraic expression. The f within parentheses with the x is pronounced f of x. Now, there's nothing special about f. Could have G or H or any letter. When you see this equaling an algebraic expression, a letter and then parentheses x, and equaling an algebraic expression, then it's telling you that's a function. Okay. So for f of x, so I'm down here, equals 3x minus 4, you might see the following directions. Evaluate f of 2 and f of minus 4. So f of 2 means we substitute 2 in every place there's an x and follow the order of operations to evaluate. F of minus 4 means we substitute minus 4 in every place there's an x and do the same. So f of 2 equals 3 times 2 minus 4, which equals 6 minus 4, which equals 2. So f of 2 would equal 2. Another way of thinking about this, if this was a y and I substituted 2 in for x here, I would get 2 out. So I'd have an ordered pair of 2, 2. Okay. Substitute minus 4 in for x. 3 times minus 4 gives us minus 12 minus 4, or minus 16. So that means that this function would go through, the graph of this function would go through the ordered pair minus 4, minus 16. Note, when we substitute, we use parentheses. It's a good rule of thumb for any substitution, including here. Again, there's nothing special about the f, the letter f. We can use any letter. So here we have g of x equals 2x squared minus 3x plus 5. We're going to evaluate g of minus 2, g of 3, and g of w. So g of minus 2, again, I put using parentheses minus 2 in every place I see an x, and then follow the order of operations. So we square first and get 4 from the minus 2 quantity squared. Then we multiply going left to right and get 8 plus 6 plus 5, which gives us 19. Same thing with g of 3. In parentheses, we put 3 every place there's an x. We square first and get the 9. 2 times 9 is 18. Minus 3 times 3 is minus 9, plus the 5, and that gives us 14. And then g of w, that just means we substitute w in every place we see x. Let's take a look at h of x. H of x equals 2x plus 1, and we're going to find h of k squared. H of x plus 1, and h of x plus h of 1. And so to find h of k squared, that means we put k squared in every place there's an x. So there's an x here by the 2. So we have 2 times k squared plus 1. And that's it. That's all we can do there. There's no solving or anything. It's just putting the k squared in every place there's an x. H of x plus 1 means we put x plus 1 in every place there's an x here in h of x. And so the x was here by the 2, so we put x plus 1 in. We'll simplify this by distributing the 2. 2x plus 2 plus 1 gives us 2x plus 3. And then h of x plus h of 1. H of x just means we rewrite h of x, 2x plus 1. H of 1 means every place there's an x here, we substitute in 1. So here's where the x was, so we substituted in 1. 2 times 1 is 2, plus 1. So 2 times 1 plus 1 gives us the 3. So we get 2x plus 1 plus 3, or 2x plus 4. We have some graphs, some standard graphs of functions. Again, you might want to take a look at this at the following links. They are Alton Newton videos on functions and graphs, including absolute value functions. When we look, we have this table of functions, and I'm going to expand this a little bit, okay, so we can see it a little bit better. Okay. This table of functions deals with standard functions. So this is where our function library comes from. Okay. So we have a function f of x equals a number. It's just a horizontal line. We have the parabolic function, which is f of x equals x squared. We have the square root function. The absolute value function looks like a v. We have the cubic function. We have the cube root function. And we have what's called the reciprocal function of 1 over x. should be semi-familiar with these graphics and these functions. We're going to do more with them in the future. We start talking more about properties and whatnot. Okay, so we're going to talk about properties next time. We're going to talk about the idea of a piecewise defined function. So in the meantime, hopefully this quick introduction to functions helped you out a little bit.